Now let's see about inserting a node into a circular double linked list at begin position, end position as well as specified position. So this is our circular double linked list which contains totally 3 nodes. Let the first node is stored at 1000 address. Let the second node is stored at 2000 address. Let the third node is stored at 3000 address. Here each node contains 3 fields. The first field is previous field. The second field is data field. Third field is next field. Previous field contains address of the previous node. Here before this node we don't have any other node. So the previous field, the first node previous field contains address of the last node. Last node address is 3000. So the first node previous field contains 3000. If we store 3000 here, then a link will be formed from first node to last node like this. Let the data of the first node is 10. Let the next field, here what is this field? Next field. Next field always contains address of its next node. Its next node address is 2000. If you store 2000 here, then a link will be formed from first node to second node like this. This is nothing but second node previous field. The second node previous field contains address of the first node. If you store 1000 here, a link will be formed like this. Let data of the second node is 20. Next field contains address of the next node. Its next node is 3000. If you store 3000 here, then a link will be formed like this. This is last node. The last node previous field contains address of its previous node, that is 2000, so that a link will be formed like this. Let the data of this node is 30. The last node next field contains address of the first node. What is the first node address? 1000 here. So if you store 1000 here, then a link will be formed like this. So arrow will be towards 1000 because we store 1000 here. And here we are using 2 variables here, head and temp. Head always points to the starting node. Starting node address is 1000 here. So head always points to 1000, and we have to use temp for traversing from one node to the another node. So initially we need to place temp at head position. Let us write the code parallelly while drawing the diagram. So void, let name of the function is insert underscore. First let us insert the node at beginning position. So this is the beginning position. So here we have to allocate memory for the node. In order to allocate memory for the node, we are using new variable, new structure variable. Here node contains totally 3 fields: previous field, data field and next field. Let address of the node is 4000. So first allocate memory for the node. In order to allocate memory for the node, the statement is new is equal to struct node star. Name of the structure is node. malloc of size of struct node. So the memory will be allocated for the members of node structure. In node structure we have 3 members: previous field, data field and next field. So for those 3 members the memory will be allocated. Okay. So next what we have to do? So after inserting this node has to become the first node. So the output is, let data here is 40. So the output is 40, 10 and 20 and 30 will be the output. But in a circular double linked list, we know that the last node next field always contains address of the first node. So this is the last node. This node next field contains address of the first node. So we have to store 4000 here. So now we have to traverse the temp till we get the last node, so that in temp next field we can store address of the new node. Okay. So how we can traverse temp to its next node? Why? Because we know that here the temp next field, the last node next field is nothing but starting address node. So we have to perform the repetition as long as temp next is not equal to head. Okay. So initially we have to place temp at head location. So temp is placed at head location, that is 1000. Next one is while perform the repetition while temp arrow next not equal to head. So if this condition is true, then traverse temp to its next node. So whenever this condition is false, then we can say that it is the last node. So what is temp? 1000. 1000 next means 2000. So 2000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So now temp will be placed at 2000 memory location. So once again condition will be evaluated. Temp means 2000. 2000 next means 3000. So 3000 is not equal to 1000. condition is true. So temp is equal to temp arrow next. So temp means 2000, 2000 next means 3000. So temp will be placed at 3000 memory location. So temp means 3000, 3000 next means 1000. So 1000 is not equal to 1000, condition is false. So the control comes out from the while loop. Now the temp is at the last node. Now we have to establish the connection from the last node to the new node. Why? Because after inserting this node has to become the last node. So in this next field, we have to store this new. What is new here? 4000. Now in place of 1000, we have to store 4000. So if we store 4000, then this link will be broken and a new link will be formed like this. So this dotted lines denotes that this is the new link. This is the new link. Okay. So the statement is temp arrow next is equal to new. So in temp next, store new. Next one is, this is the previous field. The first node previous field always contains address of the last node. What is the last node address? 3000. So if we store 3000 here, then a link will be formed like this. So this is the new link. So that's why we are using some dotted arrows, as well as this link will be broken. So next what we have to do, after inserting this node has to become the first node and this node will become the second node. So we have to establish a connection from first node to the second node. So before that, let us write the statement new arrow prev is equal to temp. So in new node previous field, this 3000 will be stored. So next node, new arrow next is equal to, what is its next node address? 1000. Where is 1000? 1000 is nothing but head. So if we store 1000 here, then a link will be formed like this. So what is the next statement? New arrow next is equal to head. Head. Next one, here this is the second node. The second node previous field always contains address of the first node. What is the first node address? 4000. So in place of this 3000, we have to store 4000. So that a link will be formed like this. So head arrow prev is equal to new. So that connections are established from first node to the second node, and second node to the first node, as well as first node to the last node and last node to the first node. But we know that in a circular double linked list or in any linked list, head always points to the starting node. So head will be moved to the new position. So head is equal to new. Head is equal to new. So head will be placed at this 4000 location. So now head will be at the 4000, and from the next we can go to the next node. So from this we can go to its next node, like that we can perform the operation. So in this way we can insert a node into circular double linked list at beginning position. Now let's see about inserting a node into circular double linked list at end position. So we have a circular double linked list like this with 4 nodes. Now our target is we have to insert a node at the last position. So what are the values here? 10, 20, 30, 40. Let the last node is 500. So the output should be 10, 20, 30, 40 and 500. So likewise we have to display the output. So here we want to insert the node at the last position. We are allocating the memory with the help of a node name called new. So allocate memory for the new node. Here node contains 3 fields. Let the address is 5000. Let us write the function now. So void insert underscore get underscore end position. So first we have to read a value. So printf enter a value, scan of %d comma ampersand value. Let the value is 500. Next allocate the memory for the node. New is equal to struct node star malloc of size of struct node. So memory is allocated like this. Next let us store the value. New arrow data is equal to value. Here the second field is data field. Let the value is 500. So 500 is stored like that. Okay. So next what we have to do. Here we have a node called head. Head always points to the starting node. And for traversing from one node to the another node, we are using temp here. Here what we have to do. So after inserting this 50 node, this 4000 node has to become the last but one node. So we have to establish connection from this last but one node to this new node. So now this new node has to become the first node. We know that in a circular double linked list, the last node next field contains address of the starting node. So in this next field, in new next, we have to store this head address as well as this previous field. The first node previous field contains address of the last node. So here we have to traverse the temp till we get the last node. So for that the condition is like this: while temp arrow next is not equal to head, temp is equal to temp arrow next. Temp is equal to temp arrow next. Okay. I'm sorry. While temp arrow next, this is enough. While temp arrow next is not equal to head, temp is equal to temp arrow next. Why? Because here our target is we have to traverse the temp till we get the last node. What is the last node next field? 1000. So this is not equal to 1000 head. So likewise we have to perform the repetition. Let us check whether our condition is correct or not. So temp means 1000, 1000 next means 2000. So 2000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. 1000 next means 2000. So now temp is placed at 2000 location. So once again condition will be evaluated. 2000 next means 3000. So 3000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. 2000 next means 3000. So temp is at 3000. So once again condition will be evaluated. So temp means 3000. 3000 next means 4000. 4000 is not equal to 1000. Condition is true. So temp will be traversed to the last node. Temp means 4000. 4000 next means 1000. 1000 is not equal to 1000. Condition is false. So the control comes out from the while loop. Now temp is at the last node. Now we have to establish the connection from the last node to its new node. So now here in place of this 1000 we have to store 5000 now. So temp arrow next is equal to what is 5000 new. So if we store 5000 here, then a link will be formed like this. So last but one node to last node, a link will be formed. Temp arrow next is equal to new. Next, after inserting this node has to become its previous node. So what is its previous node address? 4000. If we store 4000 here, then a link will be formed like this. So the statement is new arrow pre is equal to temp. So that connections are established from last but one node to the last node. We know that in a circular double linked list, the last node next field always contains address of the first node. Here the address of the first node is head 1000. If you store 1000 here, then a link will be formed like this. Okay, as well as this link will be broken. And we know that head previous, the starting node previous field always contains address of the last node. So head arrow pre is equal to new. What is new? 5000. In place of 4000, if you store 5000, then this link will be broken and a new link will be established like this. So in this way we can insert a node into circular double linked list at begin position, at end position and at specified position. Now let's see about inserting a node into circular double linked list at specified position. So this is our circular double linked list which contains totally 4 nodes, and let us assume that now our target is we want to insert a node at third position whose value is let the value is 300. Let the first node is nothing but position 1, let the second node is nothing but position 2. So this node will become the third position. So at this position we have to insert 300. So the output is 10, 20, 300, and after 300 we have 30, 40. So that is the output we have to display. Or we can assume this is as position 0, this is as position 1, this is as position 2. So the next one is nothing but this one is nothing but position 3. So 10, 20, 30, after that insert 300 here, and after that the next value is 40. So likewise also we can display. The first node can be considered as either position 0 or position 1. It is our choice. Okay. Let us assume that this is first position, this is second position. So let it be the third position. So we have to insert here. Let name of the node is new. Name of the node is new. Let the address is 4000. 4000 is already there. Let the address is 5000. So let us see the code here. So void insert yet. Let name of the function is position, POS. So first we have to read position as well as value. Here position means 3, value means 300. So first we have to read them. Next allocate the memory. So new is equal to, here for allocation of memory we are using new node. So new is equal to struct node star malloc of malloc of size of struct node. Size of struct node. So memory allocation for the node is over. So a memory is allocated like this. Okay. Next here, head always points to the starting node. So head always points to the starting node address, that is 1000. Next here we have to use a variable called temp. Here we are using temp for traversing from one node to the another node. Here what is our target? We want to insert the node at third position. So if we want to insert a node at third position, then we have to traverse the temp till we get the second position. Why? Because after the second position we need to insert the node at the third position, so that we can establish the connection from the second position to the third node as well as that new node to the third position node. So likewise, let us assume that here the position is 30. If the position is 30, then we have to traverse the temp till we get 29th node. Okay. So likewise we have to perform the traversing. So temp is equal to head. So initially temp is placed at head position. Next for traversing I am using this for loop. For I is equal to 1, I less than position minus 1, I plus plus, temp is equal to temp arrow next. Here our target is we want to insert a node at the third position. This is first position, second position, let it be the third position. So this will become fourth position and this will become the fifth position. So we have to traverse the temp till we get second position. So for that we are using this for loop. So I is equal to 1. So 1 is less than, what is position? Position means 3. 3 minus 1 means 2. So 1 less than 2, condition is true. So temp is equal to temp arrow next. Previously temp is at 1000. Now 1000 next means 2000. So temp will be placed at 2000. Next I plus plus, I will become 2. 2 less than 2, condition is false. So the control comes out from the for loop. Now where is temp? Temp is at the second position. So that means we have traversed the temp till we get the second position. So now what we have to do? We have to establish the connection from temp to new node as well as new node to this 3000 node. This 3000 is nothing but temp next. So which connections we have to establish first now? If we store a new address, if we store 5000 in temp next field, that means in place of this 3000 I stored 5000. Then what will happen? This 3000, this link will be broken. If this link is broken, then it is not possible to get this 3000. Why? Because here we are accessing 3000 with the help of the temp next. So, but we need to establish the connection from temp to new. So if we store new, what is new? 5000. If we store 5000 here, then this link will be broken. So that's why first we have to establish the connection from new to temp next, and after that establish the connection from temp to new. Okay. So now here store 3000. So if you store 3000 here, then a link will be formed like this. So new arrow, what is the statement? New arrow next is equal to. So how to get 3000? Temp means 2000. 2000 next means 3000. Whereas this field is, so this one is nothing but that one. So new arrow next is equal to temp arrow next. So in new next, in 5000 next, we stored temp next. So temp means 2000. 2000 next means this 3000. So that a link will be formed like this. So next what we have to do? So likewise here, before this node we have to store this node. So what is this field? This is nothing but temp means 2000. 2000 next means 3000. What is this field? This field is nothing but previous field. So first place constraints I am writing here. Temp arrow, next arrow, pre is equal to new. So temp means 2000. 2000 next means 3000. What is 3000 previous? So in 3000 previous we have to store this new 5000. So that a link will be formed like this. So that a link will be formed like this. Okay. So with this, the connections are established from new node to temp next. Now we have to establish the connection from temp to new. So temp arrow next is equal to new. What is new? 5000. If you store 5000 here, then a link will be formed like this. So temp arrow next is equal to new. Next, before this node we have temp node. So this is nothing but previous field. What is this address? 2000. If we store 2000 here, then a link will be formed like this. So how we can access that one? New arrow pre is equal to, this is new node, this is the previous field. So new arrow pre is equal to this 2000 temp. So if we store temp here, then a link will be formed like this. So now the connections are established from temp to new node as well as new node to temp next node. So here this code is similar to double linked list inserting a node at specified position. There are no modifications here. Why? Because the only difference between double and circular double linked list is the last node next field contains address of the first node. The first node next field contains address of the last node. But here we are inserting the node at a specified position. So that means we are not making any changes yet. The first position as well as the last position. Let's check whether insert at begin, insert at end and insert at position works properly or not. The first two statements are header files. Next, these are nothing but function declarations. First we need to create a circular double linked list. For that we are using create function, and every time after creating or after insertion we need to display the list. So that's why we use display function. Next, insert at begin, insert at end and insert at position. So these five are the function declarations, and this is nothing but our structure node. It contains three fields: previous field, data field and next field. And these are the structure variable which we use new for allocating the memory. Head always points to the starting node, temp for traversing from one node to another node. We use I inside the for loop. Next, value, in order to store a value in a new node we use value. Next, to position, mainly we use position while inserting a node at specified position, and this is main function int ch. Ch specifies the choice. Here we use while out 1. This is nothing but infinite loop. Totally there are 5 choices are there: 1 for create, 2 for display, 3 for insert at begin, 4 for insert at end, 5 for insert at specified position. So if we enter other than 5, then if we enter from 1 to 5, then this while loop will get executed. If we don't enter a value from 1 to 5, then the while loop execution will be terminated. So enter your choice: scan of %d comma %ch. Case 1 create, case 2 display, case 3 insert at begin, case 4 insert at end, case 5 insert at position. Default means exit. So if we enter other than 1 to 5, then exit, the entire program will get terminated. Next, end of the switch, end of the while gets h, and end of the main function. And this is nothing but create function code. Already we have seen this in the last class. Still, if there are any doubts, then please go through that function. And this one is nothing but display. Already we have seen this function also in the last video. So if there are any doubts, then please go through that video. Next, insert at begin. Already we have seen this code at the starting of the video. So new for allocating the memory. Next, we have to store value in the data field. Initially we need to place temp at the head location, and we have to traverse the temp till we get the last node. For that we use this while loop. While loop contains only one statement, so that's why curly braces are not compulsory. Next, the last node next field contains address of the first node. So temp arrow next is equal to new. Next, now new becomes the first node, so that previous contains new becomes the first node. So the first node previous field contains address of the last node. The last node previous field as well as the first node previous field contains address of the last node. So head arrow pre is equal to new. Next, head should be traversed to the first node. Head is equal to new. So already we have seen this code at the beginning. Next, in this way we can insert a node at the end position. So new arrow data is equal to value. Initially we need to place temp at head and traverse the temp till we get the last node. Next, we have to establish the connection from temp to new like this. So in this way insertion at ending is done. Next one is insert at specified position. This is similar to double linked list insert at specified position. So first we have to establish the connection from new to temp next and temp next to new. Next, establish the connection from temp to new. Now let us execute the program. So first compile the program. 2 errors. So temp, not temp C, it's temp only. So compile the program. 0 warnings and 0 errors. Next, run the program. So first we need to create the circular double linked list. Enter your choice 1, enter a value 10, Now if you want to create one more node, then type Y. So Y stands for yes, enter a value 2. Next, let us assume that we want to have one more node, so enter Y. Y stands for yes, enter a value 30. If we enter n, if we enter other than Y, then the control comes out from the do while loop. Next, to display the circular double linked list, totally we entered 3 values, 10, 20, 30. So that is the output there. Next, insert at the begin. For insert at the begin, the choice is 3. Let the data is 311. Now 311 should be inserted at the beginning position. So the output is 311, 10, 20, 30. Display the output. For displaying the output, we have to give the choice number 2. So 311, 10, 20, 30 is the output. Next, insert at end. So the choice is 4. Let the value is 222. So 222 should be inserted at end position. So after 30, 222 will be inserted. So enter your choice 2. So 311, 10, 20, 30, 322 will, so that is the output there. Next, insert at specified position. Choice is 5. Let the position is 3. Let the position is 3. So at the third position, insert the value. So third position means here 311 means first position, 10 means second position. So after 10 we will get the third position. So after 10 we will get that 333. After that 20, 30, 222 will get printed. So after 10, 333 gets printed. The remaining nodes 20, 30, 222. So in this way we can perform insertion at begin position, specified position.